Hi, this is Mr. Frazier, and welcome to Flipping the Classroom, Carnegie style. So, here we are dealing with Unit 3, Section 2. I introduced it yesterday on the other video, and I'm going to continue teaching about it today, and then we'll go through it tomorrow in the book. But it deals with two forms of a line. First of all, we've talked about slope-intercept form, and that's our y equals mx plus b, or the function notation f of x equals mx plus b. And remember, b is where we're starting on our graph, meaning that's the point at which we're supposed to start, the y-intercept. The m is our slope or rate of change, and it's always in front of x. And in a word problem, it's always separated by the word per, like miles per hour. So we know that per is where our x goes, and miles per hour, that the hour is our independent, right? Because it's always after the word per. So being able to write it in slope-intercept form, relatively easy. We've been doing that where we're trying to find f of x, or our answer. Okay? Slope-intercept form and standard form are two different ways of writing the same line. Okay, so let me explain it to you another way. It's just like when we had percents, and you needed to write it as a decimal, and then we needed to write it as a fraction, which would be 5 over 100. And of course, you then had to reduce it, so it was 1 over 20. Okay? So these numbers are all the same. They're just written in a different form. This is written as a percentage. This is written as a decimal. This is written as a fraction. They have the same value. Okay? The same thing happens with slope-intercept form and standard form. They have the same value, they're just different ways of writing a problem. Now, what makes them so different? When we write in slope-intercept form, we have an independent variable and we have a dependent variable. Meaning, as we write out the problem, the reason we write it out this way is because we have an obvious rate of change. Okay? We have something per something. All right. In standard form, it changes because you have a total and you have two independents. Meaning, when you're reading a word problem, you'll have two independents. When you look at it basically, like the 4 examples I have down here, you should be able to tell me which two are in standard form and which two are in slope-intercept form. Okay? But when we're reading a word problem, you choose standard form when the words you're reading have two independent variables. Now, when's that going to happen, Mr. Frazier? Well, I'll talk about that in a minute. We're going to deal with the math that involves changing slope-intercept form to standard form and standard form to slope-intercept form, being able to go forwards and backwards. We're going to talk about the math first. Then we're going to talk about how to read a problem. All right, so standard form is ax plus by equals c. Okay, so understanding what it looks like. The x comes before y. A and b are what we call coefficients. Coefficients are numbers that are in front of the letters, coefficients. Okay, now that's something you're supposed to already know. So I'm going to reiterate it again. A and b are called coefficients. They're the numbers in front of your x and your y. And in standard form, you can't have any fractions. Notice none of these are fractions. And in standard form, you can't have the beginning term, the leading coefficient, with a negative. I talked about this in yesterday's notes, and hopefully it starts to make a little bit more sense to you. All right, so we can move things around between the two forms. That doesn't mean that they're different lines. So for example, we know how to graph this. We put a point on the y-intercept, and then we move the slope. So if it's 3 over 4, I move up 3 over 4, put another dot, draw a line. We've talked about this. We've graphed this all in Chapter 2. We're going to talk about how we get different information and how we change from this one to this one and back and forth and back and forth. All right? So I'm going to slow down. understanding standard form is a way of writing the problem. Slope-intercept form is a way of writing a problem. They are the same line using similar numbers. They just have different rules. All right, so how do we switch back and forth? Okay, so let's look at a practice problem where we have slope-intercept form. This is what we're used to doing. If I need to change it to standard form, that means the x and the y are supposed to be on the same side, which means I would need to move 4x. When I move 4x, it becomes negative 4x plus y equals 2. I moved it from here to this side, and it has to go in front of the y. So, standard form is 1. Are my x and y in order on one side? And my answer would be yes. 2. Is there any negatives in front of the x? Yes. So I have to get rid of that. And this is easy. I just change all the signs. Now that's the same as multiplying by -1. But there's no reason to worry about that. I just change all the signs. If there was an inequality there, I'd have to change all the signs and the inequality. But there's not. It's an equal sign, so I just change all the signs. All right? Thirdly, is there a fraction here? Nope. Then I got nothing to worry about. It is now in standard form. Are these two lines different? No, they are not. They are the same line, just written differently. Okay, that one was a relatively easy one. So let's go to something a little bit harder. Okay, here's the next problem. It's written in slope-intercept form. I need to change it to standard form. Okay, so to change it to standard form, I got to move this over the equal sign. So here it's -2/5 x. When I move it over, it's going to become, correct, +2/5 x plus y equals 10. Everything stays where it was. The only thing I moved was the x. Okay, so first, are my x and y in the same spot? In order, x and y, yes. Second, do I have a negative sign in front of this? Nope. But I do have a fraction. So who remembers how we get rid of a fraction? Correct. You multiply the entire problem by the denominator. When I multiply that entire problem by the denominator, this becomes 2x because the 5's cancel out. It's the same as doing 5 times 2 divided by 5, which would give me 2, plus 5 times y plus, or equals 5 times 10. And now I have standard form. Now that's about as complex as the problems get, except for maybe if there was a negative sign here and we'd have to change all the signs. But I've done one where you have each. And in both, I had to get the x and y to both sides. Okay, so what happens when I have to go in the other way? Okay, so now we're going to go in the other direction. Well, why would I ever want to change standard form to y-intercept form? Because it's easier to graph. You put a dot on the y-axis, where the 2 is, just like we've been doing. That's our y-intercept. And then we would move our slope, which would be up 4/1. And then draw the graph. It's easier to graph from this one, so that's why we would change it. All right. Excuse me. So here we go. Well, now the x and y are on one side, and I got to move it. So when I move this 3x across the equal sign, what happens to anything we move across the equal sign? It changes signs. So you have 4y equals -3x plus 12. Okay, so that means it went from a +3x, and when I moved it over here, it became -3x. All right, so I'm looking at it, and I'm like, okay, now my x is on the other side of my y, and my number's over here all by itself. So am I in slope-intercept form? No. I've got the letters where they're supposed to be, but there's no coefficient in front of y. So I got to make sure that there's no coefficient in front of y. So what do I have to divide the whole problem by? 4. Correct. So when I divide the whole problem by 4, I get y, because 4 divided by 4 is 1, negative 3/4 x plus 3. And now I'd be able to graph pretty easy. Like, we go ahead and I go 1, 2, 3, right? There's my y-intercept of positive 3. Then this is a negative slope, or a negative rate of change, which means when I'm finished, the line should be going down. So I go down 3 and over 1, 2, 3, 4. Draw my lines. And that's what the graph would look like. So it's easy to graph from this. That's why we changed standard form into slope-intercept. Okay, so we've had 1 problem, 2 problems, 3 problems. Here's a 4th problem. Again, we're going to change standard form to y-intercept form, slope y-intercept. So I got to move that 10x. When that 10x moves over here, it becomes, correct, negative 10x. It was positive. When I go across the equal sign, it changes signs. What do I have to do to the whole problem now? Divide by 3. And I get y equals negative 10 over 3x plus 5. Because 15 divided by 3 is that. I leave this as a fraction unless it goes in evenly, or I might have to reduce it. Other than that, it stays like that. And now we have it in slope-intercept form. So I can graph it again. This one's easy to graph. The y-intercept is what? 5. So that means where I started. 1, 2, 3, 4, 5. And the slope is negative 10, which means I go down 10, 5. 1, 2, 3, 4, 5, and over 3. 1, 2, 3. And there's my dot, and my graph would look like that. Now, are we going to be asked to graph? Not a whole lot. Not right now. Are we going to? Yes. Eventually, we'll be graphing a lot. But just being able to move forwards and backwards through the standard form problem is probably the biggest piece. All right, so Mr. Frazier, how am I going to do this in a problem? Well, let's look at it this way. If I went to the movies, and we've all gone to the movies, are the tickets the same for everybody? No. Students get 1 price, senior citizens get 1 price, and adults get 1 price. Okay, so we're going to consider that we're going to the movies, and it's $6 per student and $10 per adult. So now we have 2 independent variables. What makes them independent? Because just because adults go don't mean kids go, and just because kids go don't mean adults go, right? You don't have to go to the movies with your parents, and your parents don't have to go to the movies with you. So you're talking about 2 distinctly independent things. So you have $6 per kid and $10 per adult. Hey, look at that, X and Y. Now, can we use different variables? Of course we can. And in your book, they always use the first letter of what they're looking for. So they write something like this: $6 per kid, $10 per adult. You can do that. I get you in the habit of always using what 2 variables? X and Y. So now we're having standard form. And then it says there was a total of $100 spent. Well, then this would be $100. But notice, everything is in terms of dollars. This was $6 per child, $6 per adult, and $100 total was spent. And this is in standard form. in this equation is always the total of something. And the a and b are both independent variables. So it doesn't matter which one we put on x and which one we put on y? No. But I would tell you to assign the first thing x and the second thing y. Follow the pattern. All right? Okay, so let's look at another example. Let's pretend they gave us how many kids went to both. So let's say instead of them telling us there was $100 in the movie, let's say they tell us 5 kids went and 10 adults. Okay, 5 kids, 10 adults. They gave it to us as an ordered pair. This time they didn't give us the total. What do we do with these? You're correct. We plug them in. So this would be $6 times 5 kids, $10 times 10 adults. And we get an answer. This one, we're just doing the math. They didn't give us a total of money. They told us how many of each were going. So now I have an ordered pair only because they've told me how much of each. And then I plug them in for how much of each. And then I do the math, plugging it in.
Mr. Peralta,
All right,
dial extension
and we get
2001. Mr. Peralta, please dial extension 2001. Thank you, sir.
we spent $130. All right, so that is 5-2 in a nutshell, or excuse me, 3-2. I apologize, not 5-2. 3-2 in a nutshell, and being able to take standard form, changing it into slope-intercept form, and back. Now the nice part is you can identify what the slope is. How? The slope is -2/5. The slope is -10/3. The slope is -3/4. Y-intercept, being able to graph. All right? That's why we move forwards and backwards. Now, could we find the slope another way? Of course we could. We could pick 2 points and do a rate of change. Okay? Or we can do it the easy way and convert it from standard form to slope-intercept form. Good luck, and we'll see you tomorrow. Please come in tomorrow if you have any questions. Have them written down. All right, guys. Bye.